everyone, it's me again. I'm Lena and I'm from the Healthcare Landscape Group. In this video, I'm going to be talking about my third DE, which is on Exponents Part 4. Now, the reason that we're continuing with the Exponents topic is that we haven't really mastered the topic of exponents yet. What I mean here is that we haven't gotten the correct answers and haven't known some of the ways to do some of the problems in the exponents part. Therefore, in this video, we're going to go over some problems that will hopefully help us to improve our exponents skills when solving these problems. So let's get started on our first problem. The first problem is that 2 cubed squared will equal 1, and then 2 squared cubed will equal 1, and then a to the power of b to the power of c will equal 1. Now, firstly, I will use the rule for the powers of powers. Now, this will equal, the first one will equal 2 to the power of 6. Why? Because this rule states that we can take 3 times 2, or we can take 2 times 3. Okay, so this is 2 to the power of 6. It also equals, the second problem also equals 2 to the power of 6, since 2 times 3 is 6. Now, how about the last problem? Well, the last problem is like an example for these to follow, but this will be the last. And this demonstrates how the law goes. So the A will go here. This will equal B plus times C, and that is the product of this number. Then for our second problem is 5 to the power of 100 will equal what? Now, Mrs. Pratt have laid out the foundation for us. She showed us the way how to do it. Like, firstly, she states 5 to the power of 99 plus what will equal 5 to the power of 100. So I found that 99 plus 1 will equal 100, and this we will use for this problem. We will use the distributive property. How can we use that? Well, if you look at this problem, this first equal sign here, and take an example for that. Maybe like 2 times 5 plus 2 times 6, let's say. So this will equal 2 times 5 plus 6. This will equal 2 times 11, which will equal 22. And the same goes for this problem over here. And this will equal 5 to the power of 99 times 5 to the power of 1. So it's like a reverse. We can reverse it back. And this will, of course, equal 5 to the power of 100. But if we write out the answer, it will be super wrong, because this is 5 times 5 times 5 times 5, and then until we multiply 5 until we get 100 times 5. Okay, the third problem. The third problem is 3 to the power of 5 times 2 to the power of 3 minus 2 to the power of 4 times 3 to the power of 4. This will equal, well, firstly, for this problem, the first step I did is that I look for any patterns, like anything in common whatsoever. Now, for this problem, at first glance, that's nothing in common, right? But no, if you look closely at the problem, there's the 5 and the 4 in here. There's 3 and 4 in here. Now, what does that have in common? Well, they all have 1 unit difference from each other. Now, 3 to the power of 5 can equal 3 to the power of 4 times 3 to the power of 2, because this will equal 3 to the power of 4 plus 1, which will equal 3 to the power of 5. And then times 3 to 2 to the power of 3 minus 2 to the power of 3 times 2 to the power of 1, because this will equal 2 to the power of 4, times 3 to the power of 4. Now, what will we do next? Well, we will use the distributive property again, like the reverse one, and we will group together the common numbers. What are the common numbers? Well, we have 3 to the power 4 and 2 cubed. We'll put this out of the parentheses times, and then 3 to the power of 1, because that's what's left of this, minus 2 to the power of 1. This will equal 3 to the power of 4 times 2 to the power of 3 times 1. And of course we can erase the 1 here because a number multiplied by 1 will equal itself. It's called the identity property. This will equal 648. We just converted this out into whatever is 3 to the power of 4 or times 2 to the power of 3. And that is for the first 3 problems. The next problem. Okay, for the next problem, the fourth problem, this will equal, the problem is 25 squared times 16 squared will equal. Now, for all of these problems, what our goal is to do it efficiently and effectively as well, but mostly efficiently. Why? Because we don't have a calculator or in a surgery room or in a room when we're discussing with the patient, right? And that's why we need to have these skills and improve our skills for this. Now, what is similar? Well, we must find the roots of this. These are all perfect squares. 50 is a perfect square, and also 16 to the power of 2 is a perfect square. This is a perfect square, and this is also a perfect square. Now, let's convert this. 5 to the power of 2 will equal 25, and then square, because this is the square here, and this is the actual 25, times 4 to the power of 2 squared. And using the rule or the law of powers, we will have 5 to the power of 4 times 4 to the power of 4, which will equal 5 times 4 to the power of 4, which will equal 20 to the power of 4. And that is my answer for problem number 4. For problem number 5. Problem number 5 is 480 squared divided by 40 squared. Now, what is common in the problem number 5? Well, if we look closely, 480 squared will equal 440 times 40. So therefore, this will equal 40 times 12, and this will equal 40 squared times 12 squared over 40 squared. And of course, we can cross out the 40 squared. This will leave us with 12 squared will equal 144. And that is my answer for problem number 5. Problem number 6. Okay. Problem number 6 might seem easy, and it actually is easy. 3 to the power of 3 plus 3 to the power of 3 plus 3 to the power of 3. Well, this we will use just the multiplication like property, and this will equal 3 to the power of 3 times 3, because there's 3 times 3 to the power of 3. And this will equal 3/4. 3 to the power of 4, because if we have plus another 3 to the power of 3, this, yes, it's 3 to the power of, because we have one more 3 here, times 3. So 3 to the power of 4 will equal 81. And that is my answer, problem number 6. Problem number 7. Okay, I think that we will be able to fit problem number 7 in here. Problem Problem number 7 is 2 to the power of 5 plus 2 to the power of 6 plus 2 to the power of 7 divided by 2 to the power of 3. And that is our problem here. Now, multiplication, multiplying, and dividing exponents is different from subtraction and addition, adding and subtracting exponents. Subtracting and adding will be a little bit more complicated than multiplying and division. Now, but we will just need to find the common pattern and then we can do it. Now, just break down all of these. I found that 2 to the power of 5 times 1 plus 2 to the power of 2 plus 2 to the power of 2 over 2 to the power of 3 because this is division. Now, why do I present it like this? Well, firstly, if we use the distributive property again, this will equal 2 to the power of 5 times 1, which is 2 to the power of 5. 2 to the power of 5 times 2 is 2 to the power of 6. And 2 to the power of 5 times 2 to the power of 2 is 2 to the power of 7. And then we will divide it all by 2 to the power of 3. And we can cross these out, and we're left with 2 to the power of 2 times 1 plus 2 plus 2 to the power of 2. This will equal 4 plus 8 plus 16, which will equal 28. And that is my answer for problem number 7. Then for the problem number 8, 9, and 10. Now for problem number 8 to 10, I will present it on the board. But for problem number 11, which is a little bit long, I think that it is wise to present it, just show it on the camera, so that we could save some time in the video, and it won't be long and boring. Now, problem number 8. Problem number 8 is 3/4. 3 to the power of 4 minus 5 times 8. This will equal 81 subtracted by 5 times 8, which will equal 81 minus 40 equals 41. Now, why haven't I used any property for that? Now, the reason is I can't seem to find any relating patterns or any trends in this problem. Therefore, I just found out the old way of doing it. Just finding what 3 to the power of 4 are, and then 5 to the power of 8. What is that? What is the product for that? And my answer is 41. But if you have any other suggestions for how to do this problem, another strategy how to do this problem, I would be glad to hear your suggestions. Problem number 9. Moving to problem number 9. Problem number 9 is 1 squared plus 1/4 plus 1/6 plus 1 to the power of 8, 1 to the power of 6, and 1 to the power of 4 plus numbers until we get to 1 to the power of 100. This will equal 1 times 50. Why? Well, if 1 squared equals 1, 1 to the power of 4 equals 1, 1 to the power of 6 equals 1, and all of these have 50 numbers, then we have 50. And you might think, why do you have 50 numbers? Of course, there's the number 100 in there, but you need to look at the pattern. There are even numbers, so that means there's a gap between that, and we will take 100 divided by 2, which is half of that because the other half are odd numbers. We will have 50 numbers, and 1 times 50 is 50. So our problem for problem number 9 is 50. Problem number 10. Okay, problem number 10 is 4 times 4 times 4 times 4 times 4. This will equal 4 to the power of 5, which will equal 2 to the power of 2 to the power of 5, which will equal 2 to the power of 10. And yes, this will equal 1024. Now, I can't seem to find any pattern here, just that we will take the basic property of exponents and take it. There's 5 of the 4s, so we have 4 to the power of 5, and just use the law of powers for powers, and this will equal to the power of 10, 2 to the power of 10, or 1024. Now for the final problem, problem number 11, I want to show it on the paper. So firstly, we have 2 to the power of 40 times 2 to the power of 13 divided by 2 to the power of 6, which will equal 2 to the power of 40 plus 13 minus 6, which will equal 2 to the power of 49. And of course, this will use the basic property of multiplication and division as well, because multiplication in exponents will be adding with the exponents, and division is the exact opposite, which is subtraction. Okay, problem B, 11b, will use the same properties, but we will need to transform it a little bit. 2 to the power of 10 times 2 to the power of 2 and to the power of 20, and then we will have all this, just transforming the numbers into something that is the same, like seeing some pattern in there. That's that is my goal for that, and how I do all of the problems. Okay, for problem number C, it's also the same. 2 to the power of 2, I chose 2 to the power of 2, not 4, because the other 2 can't go anywhere, and we need to use the distributive property, and so the 2 cannot go anywhere, if you know what I mean. And problem 11D will equal 2 to the power of 2 cubed divided by 2 to the power of 2, which will equal 2 to the power of 4. Because this is 6 minus 2, which will equal 2 to the power of 4. Problem number E is 2 to the power of 19, and then we have in parentheses 2 minus 1, which will equal 2 to the power of 19. And firstly, I thought that I would just transform out 91 and then 17 zeros trailing behind, but that is not the correct way. It's just I won't get to the correct answer. I won't get to the answer, but I will just tell you the way that I do this. Now, 91 will equal 9.9 tenths, 9 and 1 tenths, times 10, because this will equal 91, times 10 to the power of 17, and we just use the property of the other properties, and then we can switch the parentheses, and this will equal 9 to the power of 1 times 10 to the power of 18. And that is the end for my DE3 problem, all the 11 problems in the DE3, and on exponents part 4. Thank you for listening to my video, and I hope you would give me some comments on my video or any mistakes that I did in the video. Thank you for listening to my video, and I hope to see you in another meeting or another video. Goodbye, see you later.